Okay, so coming back, so we discussed the PGP activation procedure for 2G. Now we'll get a look at the PDP activation procedure for 3G. Okay, it's pretty much the same, but there is another flow involved. So we will just look into that. A user once connected to a 3G will send an activate PDP context request and it will send an APN. SDSN will determine whether the service is allowed, whether the location is allowed, the user is allowed, and then it will check the APN from the DNS and check that which APN, which GGSN is going to serve this specific APN. So based on that, the SDSN is going to send a create PDP request to your GGSN. GGSN will resolve that APN into an IP address. It will allocate a charging ID. It will allocate a quality of service. It will allocate if there is any quota based on your request, your initial, it will authenticate from OCS, it will authenticate from PCRF. This authentication also is also done in 2G as well, but those are optional things. Okay, so in 2G, 3G, both it's optional. So you get authentication from OCS, you get your profile from PCRF and all that. And based on that, you will send a create PDP context response where the primarily information carried is your IP address, you have a charging ID location, and you have a tunneling ID as well. Tunneling ID, the concept of tunneling ID is that once your PDP session is activated, so you will have a tunnel. It's a virtual tunnel that is created between your MS-ISDN and GGSN and GGSN. So all your requests will pass through that virtual tunnel. So that tunnel needs to have a tunneling ID as well, the source and the destination. For example, if you are saying that we have the tunnel between MS and SDSN and GGSN, so MS is going to randomly communicate with SDSN. So the tunneling ID of SDSN is going to be shared with the MS-ISDN. Okay, so the tunneling ID of your user plane and your signaling plane is going to be shared here. Now comes an interesting concept of RAB assignment, the radio access bearer assignment. Like I explained to you that there are a limited number of bearers that are available under the coverage of one 3G node, a node B. So always whenever you are asking for a PDP context activation, it will ensure that a new bearer is assigned to you. So this messaging flow number 4 is your radio access bearer setup. What SDSN is going to do is that it is going to send a RAB assignment request. Yes, so it will send a RAB assignment request to your RNC. The RNC is then going to send a RAB assignment request to your MS-ISDN, and based on whatever is available, whatever quality of service is supported by the RNC, what quality of service is supported by the MS-ISDN, this quality of negotiation is done. And once that negotiation is done, and the core end and the wireless end agrees on a quality of service, so a radio access bearer is assigned to carry the information from MS-ISDN to RNC and RNC to SDSN. So this is something that is additional, the RAB assignment, because this RAB is then going to be released once you are no longer communicating or once you are no longer having any activity or any uplink and downlink browsing. Okay, so setup, yes, QoS is quality of service, but quality is regarding the AMBR or download and uplink from HSS. Yes, it is. The quality of service is the same. The concept of AMBR that usually is in 4G, but what happens is that, yes, based on what is assigned to your profile from HLR, based on the service that you're requesting from GGSN, and GGSN gives a quality of service that, okay, this service will require this quality of service. Based on all that, the quality of service is negotiated that, okay, the service that the user is asking for requires this maximum bit rate or this guaranteed bit rate or this AMBR or this uplink and downlink bit rate information. And for that to be communicated to the MSISDN, you need to ensure that the radio part also agrees on that. So this quality of service communication is to ensure that this quality of service that the user is requesting and which is being assigned by your core end is agreed upon by the radio side as well. And if radio side agrees on that, in that case, that radio barrier is established. In case the radio side does not agree on that, then it will propose a new quality of service, which is then communicated in the update PDP context. For example, the radio barrier says that, okay, I cannot afford this much of quality of service, this much of uplink or downlink speed that the user is requesting, but I can afford, let's say, I cannot afford to give you 500 kbps, I can afford you to give 250 kbps. That's an example. So what happens is that at core end, it's going to be 500. So then you will have an update PDP context request informing GGSN, and SGSN is informed that, okay, the quality of service is not going to be 500, it's going to be 250. Okay, and then the GGSN is going to respond back. It will update the information with this so that there is an end-to-end. Like I mentioned, that the quality service is it's an end-to-end concept. Okay, so you need to ensure that all the quality of service is the same. Plus, when you have the DT function enabled as well, that is also communicated in this RAB assignment request. You send a RAB assignment request and you communicate to the RNC that, okay, this is the user plane tunneling ID and its IP address. For example, for user plane, you're going to use GGSN, and for signaling, you're going to use SGSN. So you communicate the tunneling ID, you communicate the IP address that is used for signaling and user plane, and then the RNC is going to respond back with in the RAB assignment response. Yasser cannot hear me. Let me check. Yes, I am unmuted. Please check again, Yasser. Yasser, I'd recommend that you disconnect and connect again. That will help you. Okay. So, right. So what happens is here in the 3G one is that in the RAB assignment response, then the RNC is going to give you the IP address of the user plane and the signaling plane. So SGSN in this update PDP context, apart from the quality of service, the SGSN is going to update the GGSN as well. That, okay, for user plane communication, you need to directly communicate with RNC. You don't need to send me this information. However, for control plane, you need to communicate to me. So your control plane is going to be MSISDN to RNC to SGSN to GGSN, and your user plane is going to be MSISDN to RNC to directly to GGSN. So that IP's exchange is also done in this update PDP context request and RAB assignment request if DT feature is enabled. So once your update PDP context response is received, your quality service is assigned, your IP address is assigned, then you send an activate PDP context accept message to the MSISDN, intimating that, okay, this is the IP address that is assigned to you, and this is the quality service that is assigned to you, and this is the tunneling ID information that is available for you. Okay, so what is the responsibility of the MS during activate PDP contact request? Like I mentioned that we will discuss this in detail, but a little bit of brief overview. MS will send a quality of service parameter which is required. It will provide an APN NI, the network identifier, and will provide a static IP address if it is requesting for a static IP address. Yes. So on RNC, there are two IP. When you do the configuration between SGSN and RNC, there are two IPs. The control plane IP is different, signaling and user plane IP is different. Similarly, at SGSN end as well, the user plane and control plane IPs are different. And then at the GGSN end, the control plane and user plane IPs are different. So when you configure a link, it's separate IP addresses. And once so it provides and once it accepts the request from SGSN, if the quality of service is not accepted by MS, then start delete the PDP contact procedure. Okay, so if the quality of service that is requested by here and it was negotiated that, okay, we cannot provide you this, if MS does not accept this, then it will not accept the PDP and it will proceed with delete PDP contact procedure. Otherwise, it will accept it, it will update the quality of service, update the IP, and then it will start having uplink and downlink communication. So the SGSN responsibility SDSN gets the info, gets an activate PDP context request. It will check the subscriber data, okay, the profile, whether that APN is allowed, whether the user location is allowed, user IMSI is allowed, and then it will select the APN based on what is mentioned in. I mean, this is a mention of how this APN selection works. So the APN is ideally the APN that the user is requesting, that APN is usually selected, and that APN is then assigned, and then the GGSN corresponding to that APN is chosen. But with time, there are some new concept introduced. For example, there's a concept of default APN. So if you're sending an incorrect APN, then what happens is that at SDSN level, there are a lot of failures. That incorrect APN or user is not guided. That a common person does not know if he's configuring an APN himself, he may configure wrong APN. So based on that, the SDSN is going to reject your request. So and then a concept of default APN is introduced. And what it does is that if there is an incorrect APN, then what SDSN does is that it will assign a default APN to it. For example, you are sending internet 1, and SDSN recognizes internet. So internet will, SDSN recognizes internet, so it will assign internet to be the default APN, and irrespective of what APN you send, ABC, XYZ, 1, 2, 3, anything, if any APN is not recognized, the SDSN is by default going to assign that default APN internet to you, and then based on that, a GGSN is selected, and then you are provided that service. But that needs to be ensured that that APN is subscribed in the HLR as well. So what we do in provisioning is that whenever we provision a subscriber in HLR, we always assign that user a default APN, so that if user sends the wrong APN, his service is not disallowed. He is assigned the default APN, his service continues. Okay. So, and that APN obviously is an NIN combination of NI and OI. Next is interrogation of the DNS. The interrogation of DNS, like I mentioned, that internal DNS functionality is inside the SDSN. So we have a host file which acts as a local DNS, and we add all the information in that as well. So SDSN will interrogate its host file to check, okay, this IP address against this APN is where. If it does not get that information, then it will check its cache, and if it is not available in cache, then it will go to your internal DNS. And internal DNS obviously will have that configuration available. So once that internal DNS provides information, that is updated in the cache as well. So that next time SDSN does not have to go every time to the DNS server. So it will update in the cache. So the next time, if it's not available in host file, you check in the cache, and if it's not in the cache, you check in the DNS server. Usually, APNs are static. You don't have a different APN. So in 99% of the cases, your DNS resolution is done from the host file, because it's static. You assign it once, you just update the IP address of this, so you get it from here. Cache and DNS server is usually involved in case of roaming, when there is an inbound roaming, so you cannot define each and every APN of each and every operator inside your host file. So then you will require the service of your DNS service. Quality of service negotiation. Quality of service is provided by the MS. Okay. Then there is a default quality of service assigned with the default APN, and then there's a quality service that's a private HLR. So the quality service negotiation is done by the SDSN to ensure that one quality service that is acceptable to all is assigned to this MSID and activate PDP context. Okay, then it will send a create message to the GGSN, including the APN as well as the quality service. Then RAB assignment we discussed how RAB is request. RAB assignment request is sent to RNC and response is received. Based on that, your updated IPs are established and the quality service is mutually agreed upon. Then you send a send message of active PTP context set to MS, where you will give the MSID and the dynamic IP address, and you will give the MSID and the quality of service information. The responsibility of the RNC is basically main responsibility is the allocation of radio resources and the radio access bearer assignment. Okay, so this we already discussed how RAB assignment is done. SDSN sent to RNC. RNC will allocate the radio resources, allocate the IU interface resources, and finally negotiate quality of services sent to the SDSN. So that is how annual session is maintained in RNC as well. Okay, GGSN responsibility is to check the APN that is provided by the SDSN. Obviously, when your request is sent, GGSN will have the APN defined and IP pool configured with it. So to check whether this APN is a valid APN or not. If it's not a valid APN, then obviously it will reject your activate PDB context request. Then it will do the quality of service negotiation as well. What is defined in the PCRF, what is defined in GGSN itself, and it will negotiate and provide the quality of service that is acceptable to all. It will allocate a dynamic IP address for the MSISDN, allocate a charging ID for the PDB content based on which your CDRs or SCDRs and GCDRs are created. So it's a charging ID which is associated with your CDRs as well. And it will return a create PDB context accept message where a dynamic IP is given, where a quality of service is given, and where a charging ID is given. This charging ID is then used by the GGSN as well as the SDSN for your CDRs, and there's a unique charging ID for every session that is created, PDB session created. And finally, it handles the update PDB context request and response, updating the IP addresses and updating the quality of service, whatever is required. Okay, so the PDB context activation is the main procedure here. Deactivation is just similar to activation procedure. We will cover this when we discuss the 4G bearer deactivation. So it's just going to be simply a deactivate PDB context request. Then SDSN is going to send a delete PDB context request, delete PDB context response, and then it will send a delete PDB context response, where or your session is going to be disabled or removed in the SDSN and GGSN as well. So there is no information available on SDSN once your PDB context is deactivated. And PDB context modification procedure is similar to your active PDB context procedure, where you send a modified PDB context request, where maybe you are sending an updated quality of service information. So in that case, there will not be a create PDB context. It will just be a RAB assignment update, and it will send an update PDB context request to the GGSN as well to inform the token updated quality of service is being requested. And based on that, if all of them agree, then your PDB context modification is accepted. Otherwise, it is rejected. If any of the NEs, RNC, or GGSN or SGSN does not agree with your quality of service that is requested in the update PDB request, so that is basically rejected. So I will add that as well. But I think if you will, when we study the 4G ones, you will have an understanding how this works. Okay, so the APN syntax, before we start that, the APN syntax in 2G, 3G, like we discussed, was that you have a network identifier and an operator identifier. So some are fixed fields, like the one highlighted in red are fixed fields. This is as per 3GPP standard. So you have your network identifier, and then you have your operator identifier, MNC and MNC. And .GPRS is fixed. In 4G, the syntax is a little bit different. The red part are the constant parts, which are mentioned to differentiate whether it's a 3G, 2G APN or a 4G APN. So it's going to be network identifier, then APN.EPC is appended to it, then there is your operator identifier, and then it ends with 3GPP network.all. Okay, from APN will not come like that. Yes, in your handset, usually the APN is the network identifier that you have configured in your hand. So it's always going to be internet. Okay. For 4G as well as 2G, 3G is going to be internet. It is the responsibility of the SDSN to append this information based on which sort of service you are requesting. If you're sending an activate PDB context, it will consider as a 2G, 3G APN. And if you are considering it to be a 4G APN, then it is going to append APN.EPC to it. Let me check. Okay, so The recording is being done. Right. So, this is how your 4G session. I think. Is anyone else having problem with the link? The link is not working. Let me just connect the link again. Let me just see whether. Okay, so Yasser is asking, okay, from APN will not come like that, no. This assignment is done from SGSN, okay, Khalid. From handset, it is going to come just internet or just Jazz or just, let's say it's CM Park or it's Zong or it's Vodafone, okay. This appending of MNC, MCC, and then .GPRS or .3GPP network, this is going to be done by the SGSN. So this is something we configure in the SGSN when we're commissioning the SGSN. We configure that what needs to be appended to the APN. Okay, so this does not come from your handset. I hope it clears. Right. Okay, so PDN connectivity request. Okay, so you don't have a session create session request from user, because as we discussed in the 4G attach procedure, the create session is part of your attach procedure. So you will not see a create session request that is sending specifically. What you send is a PDN connectivity request. Now a question may be that why do we need a PDN connectivity request? This is that maybe you have one default bearer that is assigned for one APN, and maybe you're using a different APN, and that APN requires a new session, a new connectivity, a new PDN to be created. So for that case, you will always have a default bearer that is established as long as you are attached to the network. Once you get detached, then obviously your bearer. But if you need to have another bearer for a specific service, then you will send a PDN connectivity request, and that you will have your APN as well. You will mention which APN is requesting the PDN connectivity request. So its message is called the PDN connectivity request. And obviously, based on that APN, the MME is going to consult the DNS. It will consult its local, the host file. It will next consult the cache, then the DNS, and then it will identify that, okay, which PGW is to be selected based on this. How SGW is selected, this is configured in MME based on location. So your request comes to your eNode B. Your eNode B is going to select an MME based on the location and based on the link. Which link eNode B is connected to which MME in case we don't have any pooling available. Okay, so if there is no pooling available, then one eNode B will be connected to one MME only. So eNode B will always send the request to the same MME. In case pooling is available, then based on your booty, it will identify that which MME was serving it previously, and it will send the request to that MME. But that's a bit complicated. Common understanding. We'll discuss it when we discuss the corpus of pooling. So let's keep it simple. The eNode B is going to send your request to the MME because eNode B has a connectivity with that MME. Now MME has to select SGW. MME has to select the PGW. So SGW selection is based on the location of the user, the tracking area ID. If you remember, we discussed the location that are used in 4G and its tracking area ID. So based on your tracking area ID, the tracking area code, it will select the signaling gateway. And based on your APN, it will select the PDN gateway. So just like in 2G, 3G, the GGSN was selected based on your APN. Here PGW selected this way. The SGW, the relational entity, is selected based on your location. So it will send a create session request to the SGW and sending the information of the PGW IP address as well. Then SGW will send a create session request to your PGW as well. So SGW will establish a session to handle all the user plane communication, and then PGW is going to receive this request, and then what GGSN does, it will check whether this APN has any IP pools available. It will select an IP pool. It will check with OCS, the authentication and quota availability, check with PCRF what sort of quality of service and policy need to be enforced. And then it will it will assign a quality of service based on the PCRF policy and the charging ID, and then it will send a create session response with the IP address, the charging ID, the quality of service, and some more information. So this information is then kept by the SGW. SGW will have that information with it. It will have the uplink. It will have the user plane IP address of the PGW as well to know which PGW to communicate to. And then SGW will send the create session response to the MME. Here it will not give MME. It will give the MME the signaling IP as well as the user plane IP as well. The user plane IP is that of the SGW, and the signaling plane obviously is SGW and PGW as well. And then your MME is going to send a PDN connectivity accept message to your eNode B through your eNode B to your MSISDN. Here your IP address is added. Here your quality of service information is added in this PTP connectivity accept message. Then just like in 3G, you have a RAB assignment request and radio access bearer establishment. You will have a bearer creation in the EUTRAN. So you'll have a creation of bearer of EUTRAN where you will, based on the quality of service agreed upon by PGW, agreed upon by SGW, agreed upon by MME, and provided by the HLR, whatever is agreed upon is then ensured at the eNode B end as well, to make sure that a bearer is created which has an end-to-end quality of service information available. Right? And once again, since your eNode B has a direct connectivity with MME, but your user plane is going to be between eNode B and SGW. So somebody needs to inform eNode B that what is going to be the IP address of the user plane. So that is done in this PDN connectivity accept. When it goes through your eNode B, it will inform that, okay, the signaling IP is going to be my IP, but the user plane IP is going to be the SGW IP. What is the difference between activate bearer and activate bearer? It's the same, Yasir. What do you want to ask? You're asking attach and activate bearer. Okay. See, there is no activate bearer request. Like I mentioned, like in 2G, 3G, we have activate PDP context. There is no message such as an activate bearer. At least something that I don't know of. Your bearer, your default bearer is created once you send an attach request. To create session and bearer activation is part of that. This PDN connectivity is if you need another bearer. If that bearer is not sufficient, if that bearer was for internet APN and maybe you need another APN, so this PDN connectivity is going to be for a new bearer that you need to establish. Okay, so this so that is going to be your default bearer. And this one is if you need another bearer for some specific service. Yes. Dedicated bearer, we will come to it. Dedicated bearer flow, we will come to it. Okay. Okay. So, so you have PDN connectivity accept in which the MME will inform that this is the SGW has the user plane IP address of SGW. The creation of bearer, then PDM connectivity complete. Then there is a modify bearer request. Here, MME needs to inform SGW that okay, the user plane traffic is not going to come from me, it is going to come from eNode B. So modify bearer request will give the SGW the user plane IP address of eNode B, and SGW will send a response back acknowledging that okay, this is so that all your signaling will go through MME, but your user plane, the traffic over the S1U interface will directly go from eNode B to SGW and SGW to PGW. So hence this modify bearer request. So this is something that you will now recognize when I was talking about DT. So this is what the DT function has basically. This is based on your DT function that you separate your signaling and your user plane communication. So there we just had two entities. So we used to have direct connectivity between RNC and EGSN. And here the signaling MME and the user pane is via SGW. Okay, so PDN disconnection procedure. This is very similar and simple, and why not covered in 2G, 3G? It's similar. Just a simple PDN disconnection request whenever you don't need that request. And then you have a delete session request sent to the SGW to remove all the session information that is available with it. And as SGW will send it to PGW, it will delete all the session information available, all your context information available. Then it will have a response. Based on that, SGW will have no longer have any information. And SGW will send a response. Then MME will remove all the session related information. And this will be then followed by the release of the bearer, because you cannot have a bearer dedicatedly assigned to an MME if you do not need to have a PDN service. So your bearer is going to be released, and your PDN is going to be disconnected. So if you just compare it with 2G and 3G, it's similar. You will send deactivated PDB context to SGSN. SGSN will send to GGSN. GGSN will respond back to SGSN, and SGSN will send to MSSDN, and your bearer is going to be released. So it's a pretty simple procedure. There are no complicated, and it's a very tertiary level KPI. We usually don't look into this KPI either, but just for understanding that how a PDN connectivity is removed, this is how it is done. Yes, PDN connectivity is for activating default bearer. There can be multiple default bearers that if you're requesting it against a different APN, so it can be a different one. Your dedicated bearer is always from the core side. It is PGW initiated, which we will come to. Okay. So it's PGW initiated dedicated bearer activation. For example, you had requested for a service. At the PGW level, you have requested for a service which requires some advanced level quality of service, which cannot be handled by your default bearer. So it's the PGW that basically recognizes when it communicates with the PCRF, it identifies that, okay, this is the service that user is requesting for, and this is the quality of service requirement for that. Then it's initiated by the PGW to ensure that, okay, you need to have a dedicated bearer for this, which will be dedicatedly used for this specific service. So PGW will initiate a create bearer request. SGW will send to MME. MME will send a session management request to the MSISDN. Then there is a creation of bearer between your EUTRAN to ensure that the specific bearer which is required as per that quality of service is available. And once that is done, the specific quality of service error is established, then your MSISDN is going to send a session management response, and that will trigger a create bearer response, and that will trigger a create response to the PGW, ensuring that, okay, a dedicated bearer is created. And then you can have that communication, you can have that uplink and downlink and the service usage on that dedicated bearer. Okay, the dedicated bearer, usually the default bearer and the dedicated bearer usually have the same IP addresses. Your IP address usually does not change, but it's a little bit advanced concept. And what happens is that you have a different TF, the traffic flow template, based on which the MSISDN decided, okay, on which bearer do I need to send the request to. So there will be two tunnels of each bearer, and based on the traffic flow template, the MSISDN decides, okay, on which bearer they need to send this traffic and on which bearer they need to send this traffic. Same goes on the PGW as well. There are going to be two tunnels, and PGW will check from the traffic flow template that, okay, this incoming request can be sent on this bearer, and this other incoming request is going to be sent on the other bearer. Okay, so a little bit of description. This I think you guys can read it afterwards. Okay, we can go through it. Create separate base request serving gateway. Serving gateway will send it to the MME. MME selects an EPS bearer identity which has not been assigned to the UE. Okay, because here you to have a context ID. Here we have a bearer ID. In 2G 3G it was context ID. Here it's bearer ID. The MME then builds a session management request, including the TFT, the EPS bearer quality parameters, excluding your ARP, the allocation and retention priority, protocol configuration messages, and then it will send the session message request to the UE user equipment. The UE enode and MME will establish the bearer. The UE will send a session management response, and upon reception of the response, in air, the MME acknowledges the bearer activation to the SGW, and it will send a create bearer response. And the SGW will then send a create bearer response to the PGW gateway. The exact messages that are carried as this we will cover when we will look into the traces. Okay, we look into the traces, we will open each and every message, and then we will see that okay, what is carried in this and what is the meaning of all the. I mean, there are lots and lots of fields. What are the significant fields? We will look into it. The description how these are carried and where these are carried. This is an update. This is now if you need to modify the quality of service of an existing bearer, then the PGW initiates a bearer modification request. So it's not going to be a create bearer and update bearer request with the updated quality of service information, which is reached with the MME. MME will send it to the UE, and you will have an update quality of service. The bearer is going to be updated as per your quality of service that is updated required. If it is successful, then we will have a response message. If it is not successful, the bearer quality of service is not agreed upon by the enode B or your radio side, then it will be rejected. So this is the case where an existing bearer needs to be updated with an updated quality of service. In which case PGW send initiate bearer? Okay. In which cases it sent is when you have this request, for example, this one. Okay, you are sending a service request, okay, in which you need to use a service which PGW decides that okay, this is a service, or for example, you have an incoming request which PGW see that okay, this incoming request requires a higher level of quality of service, and this quality of service cannot be handled by the existing default error. Okay, each bearer or each session or each PDP has an associated quality of service assigned to it. That this is the maximum AMBR, this is the maximum uplink bit rate, this is the maximum downlink bit rate which this bearer can process. If there is an incoming request or there is a user request where user requests for a service that needs a higher quality of service, a higher uplink bandwidth, a higher downlink bandwidth, bit rate, or what you call, or there is a service like there is IMS service, or there is another service, a radio call service, which requires a specific guaranteed bit rate, whose bit rate cannot be negotiated upon, whose bit rate you cannot degrade. There are some specific services. If those services are requested by the user or there is an incoming request, then it's PGW decided that okay, the existing bearer cannot handle this, and I am getting a request that requires a guaranteed or a maximum bit rate, and with this bit rate cannot go below what is requested in this service. So PGW will then initiate a bearer request with that specific quality of service, and the criteria is that okay, this bearer will be activated with this quality of service that I am asking. If it is not available, then this bearer is not going to be created. So this is not going to be a quality of service negotiation. This is just going to be an assignment of quality service that okay, this quality of service bearer is required by me for user to process this service. And in all of the network elements, this specific quality of service is going to be ensured. The bearer is created with this specific quality of service to ensure that it's a dedicated bearer for that specific service. Okay, good. Right, so this you guys can read. It's just similar to that, but here it is because there is a requirement in the change of your GBR or MBR or ARP QCI. What is QCI, GBR, MBR, ARP? We will cover it afterwards, and we cover into the traces. We'll have a session before that, and there I will introduce all of these terms and what do these terms mean. Okay, so we'll have a detailed understanding of that. At this level, you just need to understand how the call flow works. Okay, so I think this is the last slide for 4G session management as well. There are other procedures as well. I mean, if you look into the documentation, you look into the headaches, you are going to find some other flows as well, but those are usually secondary flows or tertiary flows. You guys can look into it via the 3GPP documentation references I provided to you, because there are so many. I mean, there is handover, there is X1 based handover, S1 based handover, but at this level for a basic level session, those are not required. When we go into the advanced level, then we are going to introduce those call flows. So till this level, I think today's content has been completed. If there is anything that you need to ask, you need to discuss. Okay, you need me to repeat the slide for the quality of service. You mean to say this one, right? Believe? Okay, quality of service is basically quality of service is a very a complex parameter which consists of many basically many components. You in quality of service you have, I mean, if we talk about quality of service, we just talk about okay the uplink downlink rate and the uplink rate, but quality of service has more information. It includes more information apart from just this things. You have your priority as well. Okay, for example, there are certain services which require priority. Okay, so if you need to assign a priority to a bearer, or you need to priority to a service that is handled in the quality of service, then you need to have, then you can also have a reliability factor as well in the quality of service to show that if there's any service that needs to be reliable, then it assigned a quality service that ensure that the service is end-to-end transmitted without any issues. Okay, then you have your ARP as well, your allocation and retention priority. For example, you have a bearer and maybe the user is requesting for another bearer, and the SGSN and your SGW, they do not have the bearers available, so it has to replace a bearer. So how is it going to replace a bearer? There is going to be a retention priority of a bearer. If you are using a bearer that is having a higher quality of service, a higher priority, then that bearer cannot be replaced. But if you're using a bearer that is a lower and a service that is requiring a higher quality of service, request is received, in that case your bearer is going to be replaced. Okay, so it basically determines the quality of service, and the main thing which you need to understand is that it is an end-to-end concept. And by end-to-end concept, I mean is that the quality of service that is assigned to an MSISDN should be the same that is being provided in the session by your radio site, and that which is being provided by your SDSN and which is being provided by your GGSN. It could not be like this, that your quality of service is different here and different here. In that case, it will not work. So you will see that there is a radio bearers, like in 3G as well. You have RAB assignment request and RAB assignment response. When you look into the 4G flows as well, again, the creation of bearer of you try and this will also include your quality of service negotiation or your quality of service information as well. And again, in case of your dedicated bearer, again, the creation of bearer will include quality of service information as well. Okay. So this has to, this is something that that is based on your quality of service, and you have to ensure that the quality of service is same. Okay. Yes, exactly. Configuration of quality of service, it need not be the same. The quality of service that can be provided, that is supported, that is usually configured. On SGSN, in GGSN, you usually configure the quality of service information, and then you need to have a cushion of negotiation as well. So if you're asking for a quality of service that is below what is supported by your any, yes, it can be handled. But if you're asking for a quality of service that is more than what is configured, then that may not be supported. Okay, would you please share with us a document with details for Q, GBR, MBR, or ARP changes? Yes, fine. I will share this document with you. I will see an easy, because documents are available, but in, I will see that which document is easy to understand, and then I will share that as well. And then we can keep it as part of the next session as well, where we will deeply study this part as well. So what is GBR, what is MBR, and what is ARP, and how is it associated with your dedicated bearer and your default bearers. Okay, so I think let's conclude this session. Once again, I'll be sharing this document with you, and hopefully I will update the video recording as well by tomorrow, maybe, or day after tomorrow. And you can, once again, these are just introductory slides. If you need a bit of advanced information, I have provided you the 3GPP documents as well, and I've also explained to you how to search that. So you can go to ETSI, you can go to 3GPP, you can search for a specific call flow. For example, you want to study in deep how does a PGW initiated bearer modification with quality of update works. So you can search that, and you mention 3GPP. So it, in search box, you will have the output where you can have the specific document which have a little bit of more detailed flows, detailed understanding of all these call flows as well. And if there you find that there is something that you need help with, you need to understand something on that, you can contact me and I can take a look at it, and we can then even discuss it in the next training session as well. Okay, fine. Right. Okay. So fine. Thank you. Thank you for being part of this session. I hope you got to learn something in this. Okay. So inshallah, next Saturday, if there is no change of plan, we will have a session most probably on these timing. If there is any change, then I will intimate to you about it. Okay. So take care. Have a nice weekend ahead. Hope to see you again in the next session.